Hello, I welcome you all to this another interesting screencast. The problem reads, determine the magnitude of the resultant force Fri equal to F1 plus F2 and is direction measured clockwise from the positive U axis. And in the second case, we have been asked to find the components of F1 along U and V axis, and in the third case, we have been asked to find F2, the components of F2 acting along U and V axes. All right, so let's begin solving. All these problems, of course, like I said, are coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So let's start with the first case. So let me call this as case 1, which is 2-4. Okay, great. So we are going to just use one method, which is just the parallelogram method, which you can you can also use the other methods using components and so on. We are using the parallelogram method. So let's draw the parallelogram. All right, there we go. So I'll draw one vector parallel to F1 and another vector parallel to F2. Let's start with F1. So this one, there we go, something like this. This is parallel, right? All right, let's draw another one parallel to F2. Okay, right, so this is F2 and this is F1. All right, let me just clean it where it's obstructing some data. And then let's draw the resultant that starts from the tails of the two original vectors to the head of the other two vectors that we have just drawn. Right. So let's call that one as our resultant, right? FR. Great. We call this one as FR. So once we've drawn this, we realize that we have two triangles that are similar. This one and this one. Okay, so it's up to you to pick which one. So I'll pick this one myself. All right, so now we need some details. We need to fill up this particular triangle with some details, and by details I mean the angles, right? The internal angles, right? So what I'll need to do is I'll come here and just draw some kind of an axis here. Okay, just some new axis there. All right, so once I've done so, then we know that this angle here, right, let me redraw this again a little bit longer, maybe from there like so. All right, let me use a straight line. Okay, something like this. Great. So we know that this angle here is going to be 30, right? This one here is 30 degrees, right? You agree? This is 30, similar to this, right? And we also know that this angle here, this one here, okay, is equal to this one here is equal to this angle here is equal to this angle here, right? Do you agree? Of course, you are supposed to. So what is this angle here? So we know that this inside angle, this one here, this one up to there, okay, see that angle there, that angle there, since we know that this is 70, right? This is 70, right? This is 70, right? Therefore, this one here will just be 70. This one here will just be a 70 minus 30, which is equal to 40 degrees. Do you agree? We've seen this angle 70 is 70, that one, right? Therefore, we can find the inner angle there, right? Which is 40 degrees, right? Agree? Great. So let's fill it in. Right, so this one there is a 40, like we said, this is a 40. So if this is a 40 degrees, what is this angle here? Okay, this angle here is just going to be equal to 180 minus 30 minus 40 minus 45, right? Okay, minus 45. Agree? Of course, you're supposed to agree. Great. So 180 minus 30 minus 40 minus 45. So this gives us 65. So this is 65. So this angle is similar to this one here, which is a 65. Great. So we have all the information that we need. So we can now straight away find the resultant, right? Using the cosine rule. So let's go here. So using the cosine rule, we just say FR is just going to be equal to the square root, right? The square root of F1, okay? So this one here is F1. Of course, this one here is F2, okay? So F1 squared plus F2 squared minus 2 times F1 times F2 cos this angle there, which is a 30 plus 65. Agree? Great. What is F1? F1, we know what it is equal to 300 newtons. F2 is equal to 500 newtons. Therefore, FR is just going to be equal to, grab your calculators, begin working out. So 300 squared plus 500 squared minus 2 times 300 times 500 times cos 30 plus 65. Square root of that, then we have a 605.10 newtons. Let me just work it out again. 300 squared plus 500 squared minus 2 times 300 times 500 cos 30 plus 65. Then square root of that, 605.10. Great. So we found one part. Let me just write this somewhere here. I just need some space. We said this one is F1. So now we found this. Now we want the angle from the positive x-axis clockwise. So clockwise. So we want this angle here. We want this angle from here to there. Okay, let's call it theta. All right, so what do you think theta is? We need to find, let me write down this. So we have theta, let's call this okay. So this is theta, but there is also this angle here. okay, that we are going to call alpha. All right. So then we know that theta is just going to be equal to 30 degrees plus alpha. So now let's find what alpha is. We are going to use sine rule to find alpha. So we just say sine alpha divided by f2, okay, is going to be equal to sine 30 plus 65 divided by FR. Okay, therefore alpha is just going to be equal to, what is alpha going to be? We know what FR is, we've already found it. So let's work it out. So we are making alpha subject of the formula. So we have F2. What is F2? F2 is 500 times sine 30 plus 65. Okay. Divided by FRR, which is 605.10. Okay. And then sine inverse of the answer. So this gives us a 55.40 degrees. Okay. 40 degrees. All right. So we have F2, which is 500 sine 30 plus 65 divided by 605.10, and then sine inverse of that 55.40. Therefore theta is just going to be equal to 30 plus 55, which just gives us 85.40. Okay, because we just feed this here, we're just feeding this here, and then we find our theta. Great. So we are done with the first case. We have found the resultant FR. We've also found the direction measured clockwise from the positive axis. All right. So let's go to case number 2. So this one is case 2, which is 2-5. Great. What are they asking us there to do? Let's check. Here they're asking us to find the components of F1 acting along U and the V axis. Alright, so what we just need to do is to draw two components. Along U and V, so that our resultant is F1, and then we find those components. Alright, so let's do so. Let me use blue. So along U and V, so we have F1. This is F1 here. Okay, so it means it will have one component this side, one component the other side, right? Because they all have to come from the same they must have the same tails, right? Great. So let's draw that. We'll draw that. Let's draw a parallelogram. So I'll have, let me draw lines first in advance, just line in advance. So let's say I'll have something like so, something parallel to you. Okay, something like this, and then another line like this. Okay, great. So this is good enough. let's now just add some details. So I'll have something like this and another vector like this. Okay. All right. Another vector like this. Okay. So this one here, we'll call it FU. Okay, this one we'll call it FV. And then we'll have another vector from here like so, and then like so. Okay. And then the resultant, of course, is the same one which goes up to there like so, which we already know. Okay. And it is 300. All right. So now what we have are two triangles that have similar geometric properties, this one and this one, so we can pick whichever one. So we are going to go with this one. So let's add some details there. All right. We need to find, let me just label this. This is FU and this is FV. Okay. So now we need some details, some additional details to this. What details do we need? So we know that this angle here, let's say FV, it will have we know what this angle is. Let's say this one, we have this angle here. We said we know what this angle is. We had already calculated it. It was what? 65. Okay, and we also know this one is what? 40. Remember, we calculated this already. Okay, this was 40. Okay, right, so that we have, this is going to be 180, 165 plus 45 plus 40 plus 30, 180. Great. So with all this information, then we know that this angle here, this one here is going to be equal to 40 degrees, and this one here is just 180. This one here, it is just 180 minus 30 minus 40, which is just going to be equal to 110, right? 180 minus 40 minus 30, 110. So this one here is 110 degrees. Is that fine? Great. So once we have all that information, then everything else becomes direct. Let's start with, it doesn't matter which one we start with. We can start with FU or FV. So let's start with FU. Okay, using sine rule. So just say sine what? Sine 30. Okay, we are starting with FU. Sine 40 divided by FU is just going to be equal to sine 110 divided by F1. Okay, so this is one equation. Then another one will be just sine 30 divided by FV equal to sine 110 divided by F1. So we have two equations that will allow us to calculate these unknowns. Okay, We have this one here, and then we have also this one there. Okay, all right. So we have all the details. We have what is called, we have F1. F1 is equal to 300, and F1 in this particular case is acting as some kind of a resultant. So now let's find what Fu is. Fu, therefore, from this equation, we just make it subject to the formula. Fu is just going to be equal to F1. What is F1? 300 sine 40 divided by sine 110. Alright, so Fu is just going to be equal to 205.21 newtons. And then Fv, using this equation, let me check Fu again. 300 sine 14 divided by sine 110, 205.21. Great. Fv, what is Fv? Fv is just going to be equal to F1, which is 300 sine 13, okay, divided by sine 110. So this gives us a 159.63. Okay, so we found F1 and F2. I mean, we found Fv and Fu. 300 sine 13 divided by sine 110, 159.63. Great. So found this part. Let's go to the second part, which is case number 3. So let's call this as case 3, which is just 2-6. Great. So we'll do the similar thing like in the other case, only that in this particular case we are looking at F2, the components of F2, these magnitudes. So let's do the same. So it's in this direction, we need this, okay, along U and along V, like so. So let's draw those. So what I'll just need to do is to just trace. Let me trace. So let me say I have something like this. I draw something parallel. Okay, something parallel like so. I draw something parallel like that, and then another parallel like that. All right. Okay, I think that is good enough. It's parallel, right? I think it's parallel. So let's use again blue for the first vector. So we'll have one like so in that direction, and another one like so in that direction. Okay, and then we'll have another one like so in that direction. Remember, we are drawing two sets of parallel, I mean parallel to Fu, and another one parallel to Fv. Okay, and another one like so. All right, and then finally we have this resultant, which is in our case is F2. So let's just clean up this part here. We clean up this part where we have some details. Right, so let's label this. So this one here, this one is Fu, this one is Fu, okay, and this one is Fv. Okay, this one is FU, this one is FV. Great. Let's add some more details. We know that this is, so we have two triangles again. We have this one and this one. We are going to pick this one. Okay, yeah, similar. We calculated this angle already. If you remember, this was 65, right? And then this one we calculated it also, it was 14. Great. So let's add some details. Therefore, we know that this angle here, this one here, this one here is just going to be equal to 45. It is similar to this angle, right? And then this angle here, we can just use, the total angles in a triangle is equal to 180. So therefore, just say 180 minus 45 minus 65, which is just equal to 70, right? 180 minus 45 minus 65, this is 70. So therefore, this is just going to be equal to 70. Okay. So once we have that information, then we can begin doing the calculation. We are going to write both equations here. We'll start with FU. So we'll say sine 45 divided by FU. This is just going to be equal to sine 70 divided by F2. Another equation, sine 65 divided by FV. FV is equal to sine 70 sine 70 sine 70 divided by F2, and we know that F2 is just going to be equal to 500 newtons. Therefore, Fu from this equation, you just make Fu subject to the formula. This will give us 500 times sine 45 divided by sine 70. So this we get a 376.24 newtons. Okay, let me just bring this one down. I bring it down like this. It is going to be more clear. Okay, great. And then FV, let me check FVU again. So we said 500 sine 45 and divided by sine 70, that's 376.24. In the other one, we have 500 sine 65 divided by sine 70. So this just gives us a 482.24 newtons. Let me check it again. 500 sine 65 divided by sine 70, 482.24. Great. I think we are done. We are done with these three problems. In the first case, we have the resultant. There we go. And we have the direction measured clockwise from the positive u-axis. Okay. Right. Let me write this. Okay, there we go. Great. And then we have the components in the second case for F1, the magnitudes, and then the components in case 3 for F2. All right, let me just create a demarcation. So we have this one there and this one there. Okay, I think this is about it, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.